Good morning. I'm Morgan Pruchnewski, and I worked with Alexandra Lawrence for Group 18, Pivers Island Coastal Observatory. Just for some background on the data set, we looked at over 10 years worth of environmental data that was collected at the Duke Marine Lab off the coast of North Carolina at Beaufort. And this data was collected from July 2010, and we looked at values up until December 2020, and it was all collected by the PICO data team. We looked at 619 different variables, which were everything from chemical to physical and biological factors. Specifically, we looked a lot into pH, chlorophyll, salinity, turbidity, and temperature. And we spent a lot of time this summer doing time series analysis, but then also looking at the impact of named storm events such as tropical storms and hurricanes off the coast of North Carolina. And throughout this entire process, we used R, and all of our code is available at the GitHub link, which we have here on the poster.
So our main analysis that we performed was time series analysis, and we used seasonal Mann-Kendall tests in order to determine the presence of a trend, and we validated this trend with the sen and found the direction of this trend with the sen slope function, as well as looking at the Kendall statistic. And then we ran ARIMA models to forecast our time series, and we tested our ARIMA functions with the Young box test and ACF and PACF plots in order to make sure that it was the best fit of a model for forecasting. And so I mainly looked at pH and dissolved inorganic carbon for the time series analysis, and there was shown to be a negative trend over time for both variables.
I also did some work with time series analysis, looking at turbidity, salinity, and chlorophyll, which all were also found to have negative trends. And I also looked at temperature, but that was found to not have a significant trend over time. Other than and rank sum tests to look at the difference when there was a named storm versus when there wasn't. And so I looked at salinity and turbidity and found that for salinity, when there was a storm, on average, the salinity values were lower because of fresh water running down through the watershed. And when there was a storm event, the turbidity was higher due to increased runoff.
And for pH and dissolved inorganic carbon, both of them had a significant difference in means between the levels recorded during a named storm and the levels recorded not during a storm, with lower pH and dissolved inorganic carbon being observed during named storm events. And so kind of the main conclusions of our work this summer has been that significant trends are present in several of the variables, and named storms do have an impact on most of these variables, and different variables respond to storms in different ways. And there are also strong correlations between dissolved inorganic carbon and salinity, as well as turbidity and chlorophyll. And some of the limitations with our work is that there's inconsistent timing between measurements. Some measurements were recorded every week, but then after some storms, data would be recorded every day. But this was not always the case, so we had to account for that in our data set. And data was not available for variables immediately after named storms due to safety concerns. So that was unfortunate because we weren't able to get the most comprehensive view of how these variables reacted to immediately after a named storm. So for future steps, we would like to continue data collection because we want to see how these trends develop over even more time. And we're also hoping that maybe one day there could be some automated way of measuring after storms, so that way the researchers aren't at risk, but we're able to get this data right at the time of a storm to see the real impacts that it has instead of just 3 or 4 days after.
And then some implications of our findings were that several of our trends were consistent with an increase in urbanization and runoff. However, the severity of them could have been impacted by efforts to create buffer zones, but that would require further analysis. And the most severe implication that I think we found from our research was that with the increase in frequency and severity of storm events due to climate change, our research that we did on how long after a storm event these different values can differ from their average is really important to consider.
Could you talk a little bit more about the impact of storms on the data? I think that's really interesting. I understand the collection issues, but what else changes in terms of the things you're measuring and how the storm impacts, your overall measurements?
Yeah, so for every single variable we looked at, it did have an impact. And for a lot of these, we weren't able to look at like the day right after a storm, but several days after you could see those values change drastically. Most of our outliers were able to be explained by storm events. And also I did work with a couple of my variables, seeing how long after a storm event, on average, it took them to return to normal. And sometimes that could be up to 20 days that it would take for that value to get back to the average levels.
That's really interesting. Yeah.
And I was,
Go ahead. Please go ahead, Alex.
and I also added some rain gauge data from Carteret County, and I ran a lagged correlation between the rainfall and pH and dissolved inorganic carbon. And while it probably was not the most accurate model because I did not have any observations recorded for the 3 days after Hurricane Florence, it did show, after doing some interpolation for that model, there was a pretty strong lagged correlation between rainfall and pH and dissolved inorganic carbon. So these heavy rains can lower these values a significant amount. And then, yeah, as Morgan mentioned, it takes a while for it to rebound. And for dissolved inorganic carbon and pH, I saw between 5 and 10 days for them to get back to the average levels.
So what was the most challenging part of your work this summer in this project?
I think for me, the most challenging part was cleaning up the data. So we had to spend a lot of time getting it into a format even that we could use. That was probably like the first 2 weeks of our process, was just doing that. And then also it was tough sometimes with like inconsistent collection dates. So I know at one point we had to change to only looking at weekly data. And again, I think the challenge is kind of trying to work around not having data right after storms. And with any environmental data set, it's going to have difficulties like that.
I agree. We also had to learn how to do time series analysis for this project, so that also took a significant amount of time.
And you mentioned using R. Were there any other programming languages you were using this summer?
No, I think we stuck pretty exclusively to R.
Okay. Had either of you used R before?
I'd taken one class with R, but this definitely taught me how to use R on a whole new level. And it was super interesting to be able to look at something and maybe a function I was somewhat familiar with, but to have to be able to apply it to this environmental data set, that was a lot of fun.
Yeah. Alexandra, how about you?
Yeah, I agree. I've used R in 2 of my statistics classes so far, but yeah, this was a big difference because usually in those classes we have data sets and assignments tailored specifically to what we're learning in the class. So this was a good way to get more familiar with R because of a specific purpose or problem.
That's really great. Thank you. Does anybody else have any questions?
I'm at the beginning of the presentation, so when everyone else is done, maybe you guys could give me the run through, but I hope other people can ask questions. Jess, maybe.
To make sure that we actually had a trend in our data. And then we used ARIMA models to forecast the time series data. And we tested the ARIMA functions with ACF and PACF plots, as well as the Young box test. And so that's what we use to kind of see the future direction of the data. And for dissolved inorganic carbon and pH, a negative trend was observed over time.
Yeah, and then I looked at turbidity, salinity, and chlorophyll, which all also had significant decreasing trends over time. However, temperature did not have a significant enough trend. And then other than doing a lot of work with time series analysis, we looked at the impact of storms by running several pairwise Wilcox and rank sum tests, and all the ones that we found had significant enough values. Specifically, salinity on average when there is a named storm event, it's lower than it would be if there wasn't a named storm event. And that continues for, I think, 21 days after a named storm event happens. And then for turbidity, on average, it's higher when there is a named storm event versus when there isn't.
And pH and dissolved inorganic carbon were both observed to have lower values during a named storm event. And so our conclusions was that we found significant trends in most of these variables, and named storm events do have a significant impact on variables, but they affect different variables in different ways. Like it takes some of them longer to rebound and some of them drop lower than others. We also found strong correlations between dissolved inorganic carbon and salinity, as well as turbidity and chlorophyll. And our biggest limitations would probably be the inconsistent time between measurements, as well as data not available immediately after a storm, because we wanted to look at storms became one of the major focuses of our project. And so for future steps, we would definitely want to continue data collection to see if these trends continue over maybe the next 10 years. And we also want to figure out if there's some sort of way that data could be recorded immediately after a storm in a safe way, so we could get more information on what that looks like.
Yeah, we've actually thought about automated samplers, but often those are damaged during storms, so you kind of pull them out. So the time you most want to collect the data is the time your instruments are most likely to be kind of destroyed. So it's a kind of a balance between the excitement of collecting the data and the likelihood of completely destroying stuff. I was curious about your time to kind of return variables to normal. And did you see variables that didn't show a hurricane impact?
I know we didn't run the pairwise Wilcox and rank sum test on as many variables as we did the time series analysis for. I think for all the ones that we ran it on, we did see some sort of a change. Just some were more significant than others.
And for dissolved inorganic carbon, that took like 2 or 3 more days on average to return back to that average level than pH did.
Yeah, so my a student in my lab did a parallel analysis, kind of inspired by some of the stuff you're doing, called breakpoint analysis, looking at only certain storms, so big storms, not all of them, because we tried looking at all different storms, and actually we found DIC took something like 50 days to return to normal. So I didn't know how you decided. You just did when the stats no longer. How did you decide when they returned to normal, I guess?
Yeah, so
I could only, sorry, you can go.
You go ahead, Alex.
Okay, for pH and dissolved inorganic carbon, I was only able to look at Hurricane Dorian and Hurricane Florence, because those were the only two that had data recorded daily for a few weeks after the storms. And for those, I just plotted a line on the plot that was the average value of September and October, and then just looked at when it got within, I forget how close, but within a certain distance from that average line is when I determined that it reached the average level again.
Yeah, salinity and turbidity had a lot more data to work with. So I basically kept running those pairwise Wilcox and rank sum tests on a for loop, looking at when I got to a point where there was no longer that difference. So for salinity, it was 21 days until there was like no longer a significant difference between when there was a storm and there wasn't. And then I think for turbidity, it was something like 19 days.
Cool, thank you.